moved on to bringing more efficiency and effectiveness in our test automation solutions by creating frameworks. So today, I'm going to talk about test automation frameworks and how we can take our existing frameworks to the next level where we can bring in more effectiveness and more efficiency in doing an end-to-end test automation for our present day web applications or desktop applications. Throughout the presentation, I would have a number of demos that I'd like to share with all of you, but primarily I'd like to stick to this agenda today. I would talk about a common test automation case, then you would see how framework solves these problems that we see in test automation. Then I would talk about how we can make our existing frameworks and test cases that we automate using frameworks more effective using something we call as a domain-specific language for testing, a DSL. Then you would see how we can take our frameworks, take our existing test automation solutions, and do a little bit more than just doing regression testing, doing layout testing, doing stress testing, and other things beyond just doing functional testing of the application. And finally, I'll end with summary and a bunch of next steps where I'd like to take whatever the solution that we have right now in hands. Let's talk about a common web application that we see nowadays. Now, any modern day web application nowadays have huge set of requirements when it comes to testing, because the users that are trying to access the application, they have various different methods and ways to access the application. You have your web browsers running on any of the machines, the PCs, Macs, then you have mobile devices which have web browsers on them. So the web applications can also be accessed from mobile devices. So we have now smaller form factors of mobile devices, the bigger form factors of your machines, laptops, PCs, and then various different form factors within the devices itself by changing the orientation of the device. And then now we're focusing a lot on agile development. Go to the market, go to the end users as early as possible. We are crunching down our development cycle. How do we make sure that with test automation, with effective test automation, we are able to support the development in maintaining those development and deployment targets? With these challenges in hand, what are our possible solutions available in the market? Well, you obviously have a bunch of popular commercial tools, but I prefer using more of open source technologies because of their cost effectiveness. Yes, they lack support, but then the extensibility that you can derive out of existing open source technologies is huge. You can blend them into whatever solution you want to build. That is something that the existing commercial tools do not really support or provide. Hence, when you talk about test automation of web applications, your HTML-based applications running inside web browsers, you have Selenium. It's a very popular JavaScript library, and it has handles available for all the development languages that you can think of. Java, Ruby, C, C++, C#, Perl, Python. And then, when it comes to automating applications that are built for mobile devices, the mobile apps, the smart OS apps, you have a bunch of open source solutions available, open source tools available. One of them is Appian, which is built on the Selenium core itself. It enables you to do test automation of your mobile apps as well as web apps running on side mobile browsers. Then you have Calabash. It's more of an instrumentation kind of an API, which enables you to perform any user interaction on a mobile device in order to automate the tests that you want to perform on web applications or desktop applications on mobile devices, mobile platform. Then you have a bunch of other technologies, tools available using which you can essentially perform all the remaining things that you need to do for test automation, like automating your day-to-day macros on your desktop, automating shortcuts, automating keyboards, a bunch of other desktop applications and all that. Flash, that has right now gained a little less popularity, but it was very popular a couple of years ago. And reason was it was really easy to develop rich internet applications using Flash, Adobe Flash. And those applications were available as your desktop apps or as mobile apps running right inside the browsers. So there's a tool, a framework rather, that is built by Adobe themselves, who built Flash. It is called as Genie, which is used to automate any Flash-based applications and applets. It's not a very popular tool, but it's still there, and we try to use it. But what is the problem with all these tools and solutions already available in the market? Well, there is no silver bullet. That means that there is no single tool or solution that is already available in the market that I can use and that can automate all possible parts of my application, all possible sections of my application. For instance, I can pick Selenium. It can automate web applications. Wherever there is HTML code inside the browser, it can very well automate all those test workflows for me. But the moment you hit an HTML page which has a Flash applet embedded inside, you cannot do anything inside the Flash applet using Selenium. Or what if you want to automate a desktop application that does not run inside the browser? It's installed on your machine, you launch it and you try to perform actions on it. Selenium cannot help you in doing that. So in order to automate these other kinds of applications, you have to pick some other solution. So every solution out there that is already there has some limitations or the other, and hence you cannot have a single solution and you cannot apply, repeat it on all possible test automation problems and say that, okay, this would work everywhere. Right now, there's no such solution. So how do we deal with such problems? Well, we build test automation frameworks. And what do we do in test automation frameworks? We try to integrate multiple such tools together so that the good of all the tools can be integrated into a single solution, and a solution such that it is really easy for the automation team, for the manual tester, or whoever is the consumer of the solution to create the test in a rapid fashion, run them, maintain them on a longer product development cycles. And how do we do that? We integrate multiple tools. Let's say it's a web application which has some Flash components and it also has a mobile app. So I would integrate Selenium, APM, and Genie together into a single framework and create a standard test automation API on top of these tools. Each of these tools would have their own APIs, would have their own interfaces. But if you try to write test cases, scripts on each of these interfaces, you would end up writing 3 different scripts for 3 different forms of the application. But how we do it? We create a generalized standard API on top of a wrapper on top of the existing APIs of all these tools, which becomes our standard test automation API. My language automating my test cases, my language for scripting the test cases. And then in my test cases, in my scripts, I would use this language. How does this help me? Well, with the same vocabulary, I can now automate web applications, I can automate Flash applications, and I can also automate interlinking end-to-end scenarios that start on web application and end up on a desktop app or a mobile app for that matter, right? So imagine you have test scenarios where you're trying to test the end-to-end functionality, integration of end-to-end things, a complete end-to-end workflow. And then on top of that, once we build these frameworks with the integration with the standard API available, we throw in some gems in there, gems like continuous integration. The developers have already been using a lot of continuous integration. They use it to build, to check in the code, to build and to run their unit tests. Now, if we provide them a way to run our automated tests as part of the continuous integration, the feedback that they were getting when we were running the regression tests would be much faster. So now we hook up our automated tests as part of the CI system of the developer. So whenever a build happens, the unit tests are executed as part of the build, but the automated functional tests are also executed as part of the build. So the build is sanitized from not just the unit level, from the integration and contract level, but also from the functional perspective also. And the developers have a very quick feedback of it. Let's have a look at a quick demo of one of the solutions that we've implemented at Harvard Catalyst for one of the products. And in this case, we are actually using continuous integration. I'm not actually showing the exact version of the CI server that we are using, but I've actually hosted something right on my machine so that I can demo it properly and have more control over my demo. So there's a product called Eagle Eye, and we have built a lot of automated tests for this product. And they are built using Selenium, and we've built a framework around it, and using that framework, we are trying to automate all possible end-to-end scenarios and test cases for this tool. And then it uses the same technologies that developers are using to do continuous integration. Maven for build tool, CI Bamboo or Jenkins to run, to schedule your builds, and make the reports available and all that. So in this case, you have Jenkins in front of you, which is a popular open source continuous integration server. And what I've done is I've created a project under it, Eagle Eye, which runs my automated code, a test automation code that I've created. When I click on the build now button, you would see a browser would pop up and a bunch of tests will be performed inside the browser. And right now I've just hooked up few tests which just test the header and footer links, availability of the links, and essentially whether they are pointing to the right page on a couple of pages of Eagle Eye. So let me click on build now and see what happens. The browser has launched, it would go to Eagle Eye. So it's going to the Harvard Eagle Eye node. It would verify the header links and will move on, clicking on each of the links, verifying that they end up on the right page. And at the end, once all of these tests are executed, the results are provided back to the CI server, and we have a standard place where we can look at the results. And developers would have feedback by knowing the status of the build, whether these tests were passed on the build or not. So the build actually failed, and let's try and analyze the test results and see what was the failure. So if I look at these tests, these are all the tests that were executed, and one of them failed. That is the reason we have a failure. So out of 13 tests, one test was a failure. So out of 12 tests, only one test failed. But we have an instant feedback of the automation test cases, right? And the developers don't need to contact us in order for us to execute the test. Whenever the build is available, we can have this as part of the CI system, and they can run the test, and it's all up there. All right. Now let us see how we can make whatever we have more effective in terms of the test coverage that we are providing, in terms of the maintenance that we have to do in order to make sure these tests are available on longer running project life cycles, and also making sure that it's easier to add newer test cases inside this test automation solution. Let's try to understand that through a small story, what the problem is. Consider a search form of an application. It has basic controls. You have all these words, search by words, search by exact word or phrase, some filters like subject category or more of these words. And so there are a bunch of fields using which you can perform search for articles inside the database of an application. Now in order to automate this, I created a manual script, and then I created an automation script around that manual script. So what was the manual script? You have these 6 steps. Launch search page, type Selenium in all these words text entry, type test automation in subject text entry, click on the search button, verify result display, verify result contain the keyword. It's the name that we search for. So there's a result list that is displayed, and we are making sure that the keyword is actually available in those results. The search functionality and this form is working properly. But what happens is, a few sprints down the line, the UX and UI developers decide that we have a better way of displaying the same form. Rather than having a text entry for subject category, now they have a drop-down list, a list, because there's a static set of items that you can choose from. Now what happens to the script that I created a few sprints back? Does it still run? Well, it does not. This time the script and the test case would fail, because there's a step that points to and says that type test automation in the subject text entry. But subject text entry is no more there on the screen. So this test and the automated script that is tied to this test would essentially fail. How do we solve this problem? How do we make sure that our test automation test cases and automated scripts do not become brittle to changes that very frequently happen over a period of development of an application. How about if we change the way in which we create our test script, write the test case? How about if we write the test case at a little higher level by stripping off all the technical structural detail of the page from the test workflow itself, the test case itself? Look at these steps now. Launch search page, perform all words search for Selenium with subject as test automation, verify results contain keyword Selenium and belong to subject category test automation. It's pretty much the same test case, but I have rephrased the test case in such a way that it is easier for even the manual person to understand what this test is, because now we are talking in a language of the subject matter expert for this product. We're talking in his vocabulary, in his words, commonly used words. And then we're using that for test automation as well. Now if you look at this test is valid for both the versions of the screen of search form, right? Because we're not talking about the technical structural detail of the page in our test case. So the test becomes, it is no more brittle to changes in these kind of changes in the UI. And still the test is valid and it covers the kind of coverage that we want to provide in the test case. What did we achieve by changing the wordings of the test case, the way we arrange or describe our test case? Well, there essentially are multiple levels at which you can describe your test case. You can describe it at the UI level, where you have to deal with the structure of the page, the elements, the presence of the elements, the behavior of those elements, how do you interact with those elements, or you can describe the test at a user activity level. For instance, for a login form, I can say type in username in username entry, type in password entry, click on the login button. Or I can say login with username X and password Y. Both of them mean the same, both of them provide the same coverage, and in the second way, I have stripped out all the structural information. Now, even if the UI of the login form changes, my test still remains valid. That is what we're trying to do. We're trying to change the level at which we describe the test case to a little higher, to a behavior level versus to a UI structural bound level. And by doing that, we bring in more stability and more robustness to our existing test cases. But how do we actually implement this into test automation? This is all test cases that we have in front end. Now we want to make sure that they are automated. How do we do that? Well, we use a technique called as domain-specific language for tests. Domain-specific language, very popular. You have a vocabulary that describes all the actions that you need to perform in a particular subject or a particular application. So in order to make sure that we are describing the test case at the behavior level, first we create that common vocabulary. What are we going to call when use the phrase? What phrase are we going to use when we say we are going to log in with username and an X and Y? What phrase are we going to use when we say we are performing activity X inside the application? They are already there. The manual testers, when they are creating the test cases and the requirements when they are generated, the acceptance criteria when that is created, we already speak in that higher level vocabulary, the BSL in which the application is, the functionality of the application is. But when we do test automation, we try to create our test cases at the structural level. Why not we continue using the same vocabulary even for test automation? So how do we do it? Well, we create the vocabulary, the domain-specific language of the application using a technique called page object tracking or UI modeling. That is something that we very frequently use in test automation nowadays. You have your application, which can be divided into smaller sections, the commonly used sections like headers and footers, then sections that are very specific to one page or one area of behavior of the application. And then you can further divide that into behavioral characteristics. On login page, I can do a login with valid username, or I can do login with invalid username. I can try doing a login with invalid username. there are two different behaviors. In the first case, the system would throw me back to a different page. In the second case, it would throw me an error page. Right? So rather than defining the structural test cases, how about if I define the behavioral test cases and then create my standard automation API at the DSL level itself, rather than creating at the structural level of the tools available. That is what we're trying to do using our framework. We're trying to define a domain-specific language at a little higher behavioral level so that the lower level details can be completely hidden out from the test cases. So the test cases are no more susceptible to change in the UI, and yet we have a way to automate the application. Now there are a number of other tools that we use in order to continue doing automation in similar situations. Normally we would pick test runners that are in line with what development is using. So development normally uses TestNG, JUnit if it's a Java application, for unit testing, for integration testing, for contract tests. And we normally end up using the same tools for our automated functional UI tests as well. How about if we change our tools to behavioral development description tools like Cucumber, like Spark, which is a very similar library in Java for Cucumber, like JBehave, which is a very popular library for behavior-driven development and behavior-driven test automation, like RSpec, which is a Ruby-based specification by example library using which you can define your test cases at a behavioral level and still do test automation. Let's now have a look at a demo of this effective automated test where we are creating the test cases and automation at a behavioral level. Okay. So the application that I've built this demo for is imdb.com. Now, why did I choose imdb.com? Because it has two different versions of the same application. You have the imdb.com website, which is open in the browser, and you also have the imdb mobile app. If you look at the test cases that you would really want to execute on each of these two different forms of the application, they remain essentially the same. You make sure that you are able to perform a search for a movie or a character or an artist on the IMDb database, whether it's the web application or whether it's the mobile application. Right? What differs in these two applications is the way user interacts with these two applications. But if you define the test cases at the behavioral level, at the user activity level, you strip out all the user interaction details from your test case. The same test can be executed and remains valid to validate one functionality on both the imdb.com web application as well as the mobile app. Let us see how that happens. Let me execute a test first. This is a Ruby-based test, so it uses RSpec. So you could see the results right here, and we also have an HTML page result. So when I say run specs, it would launch the browser. So it is using Selenium internally to perform the automation. And then on top of it, it was really fun. Let me execute this once again. So essentially, we are performing a search for a term and making sure that the web application returns results for that term. It's the most critical test case that we would execute on imdb.com web application. And you can see what test was executed. You have imdb.com, IMDb application, which is the context. Homepage of IMDb application should allow performing search. Perform search should return result list. Then on the result list should display correct results for the search term performed. Now this is a test case that is described at a behavioral level. You have a lot of data available at the back end using which you can drive the same test case. I mean, you can have as many search terms you want, and you can do data-driven testing of the same test steps with different test data. The data may change, but the workflow, the scenario, the behavior would always remain this, which is perform a search and verify that the results are available. How about if I run the same test case on IMDb mobile app? Now, in order to demonstrate that automation that is running properly, I have a mobile connected on this device, and I'm going to do a screencast because you won't be able to see. So I have a screencast running on my system for my own device, And what I'm going to do is I'm going to make a small configuration change in the config of my test case. I'm not going to change the test. It is the same test that is going to run, but I'm going to change the config, the app mode to mobile rather than to web. So my automation framework knows that I have to run the same test, but this time on a different platform, on a different version of the application, which is mobile app. I save the configuration, and when I run the test again, you would see that in the mobile, IMDb app would be launched, it did, and the same test would be performed, search for the same set of keywords, the same data that we use in IMDb.com web application, and so the same workflow is being executed. Now we are able to use the same test case and validate and do automation of the same test case across different forms of the application. That is why we try to create test case at the behavior level, because they are not susceptible to the changes, the activity, the structure of the application, but yet they are sufficient to do our test validations. Alright, so we get the same results here as well. So when we do all these changes in our framework and make sure that our test cases are now created at a behavior level and we are trying to automate them, what do we gain out of this? Well, the tests now have become more readable. They're now more fluent, because we are trying to describe our test cases not at a structural or technical level, at a language which only the engineers would understand, but at a language which is generally used in communicating the requirements and the behaviors and the features of the application among a cross-functional team. You have the product owners, you have the development, you have the QA. Normally QA and development talk at a technical level, and the product owner normally just talk at the requirement, the vocabulary, the feature level. But when we have this kind of a DSL available for test automation and for creating our manual tests as well, now we have a common platform in which we can communicate with everybody. Everybody would be able to understand our test cases, and not just that, everybody would be able to contribute to adding more test cases in this list. So we have opened up our doors by stripping down the technical things, by making it easy for anybody to create test cases, and then by doing so, we are now able to create more effective test cases, right? Because everybody can put in their thinking hat in automation, in testing, and write the correct set of test cases which would be more effective in order to automate or in order to run, to validate the application and its acceptance. Then, with a DSL in picture, with the kind of framework that we have at the back end, the amount of coding that we have to do in order for us to automate these test cases across the different forms of the application, or for that matter across different features of the same application, that has reduced a lot. We don't actually have to code for each and every click, but we create predefined keywords or domain-specific language keywords once, and we reuse those keywords as much as possible, because now we have a fixed vocabulary of defining the test cases. And because of that, because of the same very reason, these tests, because now they are not as brittle and as susceptible to UI changes as they were earlier, they are a little easier and a little less expensive to maintain over a longer running test automation or project development cycles. So it's a win-win at every level. All right. We have seen how we can do functional test automation with our frameworks. But there's some validation, some amount of testing that we normally do not do through our automated tests, through our UI tests. What is that testing? Let me show you that by an example. Look at this application. It's a basic web page. It has a sidebar with sign in and additional functionality, some content. So basic web application. Now in order to test this application, we created an automated script. I'm going to run that script and let's see what happens. going to run these, the test that I created. It has launched the browser, opened the application inside it, and performing all the necessary steps that are detailed by the automation test script, and it has given me the results. So there were no failures. The test that was executed was go to the home page, verify that there is correct title, the correct welcome message, sign in link is there, register link is there, click on the sign in link, perform the sign in operation, and make sure the welcome page is displayed. But I'm not sure whether you noticed a weird thing about the application. If I reduce the size of the window, you would see that the sidebar is actually wrapped behind the main content of the application. And that is how it was when I executed those automated tests. The links were behind the main content of the application. Now, when a manual person is trying to execute these tests in this smaller resolution, let's say he's trying to do it on a tablet which has a form factor of 1024x768, a smaller form factor, he would see this problem. He would say that yes, there is a problem, there's a defect, there's a UI issue, a layout issue somewhere there, and because of which I cannot proceed any further. I cannot click on the sign in link because I cannot see it properly. But on the other hand, the automated test that we created, which is created at a structure level, they would run properly and they would give the correct, they would give a pass result. Right? The automated test would run. If we run that test once again, and you would see what happens. So the screen size is smaller, the sign in link is still hidden behind the text, but the automated test is able to find it and run the test properly. Why is this happening? Because Selenium works at that structural level of the application. It does not validate things by looking at it, by how they appear, but how they are in the DOM of the web page. Right? If the element is available, it would perform a click on it. Whether it is behind another element, ahead of another element, Selenium would not take care of that. So for doing validation of functionality, that amount of coverage, your functional automated tests really provide you the best way of doing that. With your existing automated tests that are written at the structural level, you can validate the functionality of the application, the behavior, the workflows. But what do you miss in these tests? You miss the layout issues, the look and feel, the misalignment issues that you right now are not able to automate with existing functional test automation, functional UI test automation code. That is a huge thing. When you execute these tests manually, you would be able to very easily identify those issues. But the automated script, they're not intelligent enough, they do not identify such issues. So how do we make sure that our framework, they're not just doing functional testing, but they're also validating the layout of the application if it's a web application. And more is the case